Okay, now we're going to talk about the theory behind the idea of filtering and mapping and reducing, at least as I understand it. So the reason that we should think about this is that the order of operations really matters when you're working with extremely large data sets. So if you have 10 items, you can, if you have 10 cards on the ground, let's say playing cards, you can sort them almost by eye. You can move them around, move a couple cards, and they're suddenly in order. But if you had numbers from 1 to 100 million, and they were all randomly arranged on the floor, it would be a really big floor, but you could have them arranged on the floor, and you would want to have some particular strategy for doing that. It wouldn't be very efficient to just do it in an ad hoc way. And there are algorithms for doing sorting, and they matter not so much with little data sets, but with big data sets. In the same way, working with large collections of images, the order of operations really has an important effect. So we'll describe these ideas, and then I'll give you some examples, or one example of how that, to try to make that, give you that feeling for how it would work. So the operations filtering. Filtering means selecting a subset of images based on some criteria that we're interested in. Mapping is manipulating each image in a set, and the idea is to create a new set of values. And reducing is to summarize that set of values. And so you'll see here on the next slide, and also in the book chapter, I've highlighted them with these colors, just taken from Google Drive. The colors are purple for filter, green for map, and blue for reduce. And so the problem to consider, the problem that I write about in the chapter, is suppose you need to go shopping for milk, and you have two criteria for determining where to go get the milk. You care about the location and the price. The store needs to be close enough to your home that you can get there. You don't really want to know about inexpensive milk, but that's on the other side of the world. And we're looking for the cheapest price. I don't want to know about very expensive milk in my hometown, in the location where I am, but I would like to have some way to sift through and come up with an answer for what is the cheapest price. So in this case, the operations correspond to this. Filtering is like selecting the stores that are close by. Mapping would be finding the price of milk at a store. So that is, I have a set of stores. I want to make a request to each store. And reducing is to take that set of prices, maybe that I have written on a piece of paper, and then go through them and determine the cheapest price. So as you'll see in the next example, there's something important about the order that we do it in. So if you can see this, it says, what is wrong with this plan? And those of you in the audience, maybe instead of speaking, could type into the chat. And so the idea is, with Earth Engine and other programming languages that are arranged like this, you move from left to right. And that's the order of operations. So the idea would be, let's get a list of all of the stores on Earth, and then let's filter for the stores that have milk. And so at the end of, at this part of the calculation, we would have a list of all of the stores on Earth that sell milk. Then we would make a phone call to every one of those stores. We will call, in this case, the way this is arranged, every one of the stores on Earth that has milk, and get their price and write it down on a piece of paper. Then, taking that list, once we have finished calling all of the stores on Earth and we have all of their prices, we would then screen out just the ones that are nearby and say, okay, I have the prices all assembled, but I only want the prices that came from stores that are nearby. Then I have a list, maybe it's about this big, and then I want to go through that list and find the minimum value. So if you think about it, that will work. It will take a really long time at one particular step, and that is calling every place on Earth to find out how much milk costs. And so if we send it a set that is extremely large, then this operation of mapping will take a very long time or will require a lot of resources. You could imagine in real life, you could hire 1,000 people and have them make all these phone calls, I guess, and it could happen, but it would really take a long time. Instead, and so it requires, as I've said here, that we call every store on Earth that sells milk. Instead, we can do it this way. And here I'll arrange it kind of vertically with a little comment off to the side. So we would take all stores on Earth, and I think I will actually remove that. It takes all stores on Earth, and then let's first filter the stores that are nearby. So then we would have only the locations that are near us when we get to sort of this step. Then we would say, I'll just call the stores that are nearby and I'll find out if they have milk. So that is another limitation that sort of narrows the set to be stores that have milk. Then we would get the milk prices from each of those stores. It's the same operation, but done on a smaller set. We would request just a few prices relative to the previous example, and then determine the minimum value would allow us to find the smallest price for us for this example. And so that is the basic idea. That's the theory about how to think about it. As you see here, we have filtering happens first, then mapping, and then reducing. And that's the theory. That's the idea of how these parts should work together. So if you haven't done so already, let me encourage you to go to the book scripts in Earth Engine. Now, you don't need that expressly in order to be able to do this, but if you want to also push the button and see the numbers, you can do it as well. All right, so I'll stop now for a moment for this part.